In today's presentation, we are going to learn about parity. So parity is used for detecting errors during the transmission of binary information. So in parity, an extra bit is added along with the binary message to make the number of ones even or odd. The message along with the parity bit is checked at the receiver side for detecting the errors. So there are two types of parities, even parity and odd parity. In even parity, this added parity bit should make the total number of ones as an even number. And in odd parity, this extra added parity bit should make the total number of ones as an odd number. Now we will see how to add the parity bit for a particular message. So for example, the binary information is 110010. For this data, if you want to get the even parity bit, first we need to count the number of ones in the data. How many number of ones are there in this data? 1, 2, 3. So number of ones are 3. So if you want even parity, in even parity, the parity bit should make the number of ones as an even number. Now in this information, number of ones are 3, which is an odd number. So to make it as even number, the parity bit must be 1. So what we are doing here, this parity bit will be added along with the information. So parity bit is 1, then the information as it is 110010. Now this will be transmitted. So now here in this data, along with this parity bit, if you are counting the number of ones, 1, 2, 3, 4. Number of ones became 4, which is an even number. So this is how we need to add the even parity bit. That means in even parity bit, total number of ones should be an even number. Now for the same data, if we want an odd parity bit, so here the number of ones are 1, 2, 3, 3, which is already an odd number. No need to make it as an odd number, so the odd parity bit will be 0. And how we are transmitting the data? We will be adding this parity bit along with the message. So here the parity bit is 0 and the message is what? 110010. So 110010. So this will be transmitted. Now here if we count the number of ones, 1, 2, 3. Number of ones are 3, which is an odd number. So in even parity, total number of ones should be an even number. In odd parity, total number of ones should be an odd number. So now in this table, we'll see how to assign the even parity bit and odd parity bit for a 3-bit message. So if it is a 3-bit message, as we know, we can write how many combinations? 2 power 3, 8 combinations from 000 to 111. Now for each and every message, we will see how to assign the even parity bit and odd parity bit. Now for the first message, so here the first message is 000. So in the 000, we need to count the number of ones. So number of ones here it is 0 and 0 is considered as an even number. So here no need to make it as even, so the even parity bit will be 0. Now for the same message, odd parity bit will be 1. How we are getting that 1? Here the number of ones are 0, which is an even number. So to make it as odd number, we are adding the odd parity bit as 1. Now we will see the next message 001. This is the message. In the 001, how many number of ones are there? 1. That is an odd number. So what will be the even parity bit? In order to make it as even, we have to add 1 as the even parity bit. So here, how we will be transmitting this data? Parity bit and the message. That means parity bit is 1, message is 001. So the total number of ones becoming 2, which is an even number. Now again for the same data 001, what will be the odd parity bit? Here number of ones are 1, which is an odd number. No need to make it as odd. So the odd parity bit will be 0. Now same way for the next message 010. In 010 also number of ones are 1, which is an odd number. So no need to make it as odd. Odd parity bit will be 0. Same time here number of ones are odd number. To make it as even, the even parity bit should be 1. Now we will see the next message 011. In 011, how many number of ones are there? 1, 2. 2 ones are there. That is already an even number. No need to make it as even. So the even parity bit is 0. But here in this message, number of ones are 2, which is an even number. Then what will be the odd parity bit? Odd parity bit must be 1. So that the total number of ones will become 3, which is an odd number. Now same way here 100, number of ones odd number. So even parity bit will be 1 to make it as even. Here it is already in odd parity, so the odd parity bit will be 0. Again 101, number of ones are 2, which is an even number, so even parity bit will be 0. Now odd parity bit will be 1. Again, the same for 110, number of ones are 2, which is already an even number. So the even parity bit will be 0. Same time, 110, number of ones are 2, which is an even number. To make it as odd parity bit should be 1. Now we will see the last one, 111. Data is 111. How many number of ones are there? 3, which is an odd number. To make it as even, the even parity bit must be 1. At the same time, because it is an odd number, no need to make it as odd, so the odd parity bit will be 0. From this table, we can understand one relation between the even parity bit and odd parity bit. Odd parity bit will be the complement of even parity bit, or we can say even parity bit and odd parity bit are complement to each other. So now we will see an example for checking whether the code is correctly received or not using the parity. So see here, the received code is 10000001. Check whether the code is correctly received or not if odd parity is used. So here odd parity is used. Odd parity is used means what? The number of ones must be an odd number. So here in the received code, how many number of ones are there? First one, then the last. So 2 ones are there. So here odd parity is used, but when we are counting the number of ones, that is 2, that is an even number. That means there is an error happened in the code. So 10000001, number of ones are 2, which is an even number, hence the code is not received correctly. While counting the number of ones, if it is an odd number and odd parity is used, that means there is no error. So in this way, we can detect errors using the parity. So that is why the parity is known as an error detecting code.